Imagine everything you thought you knew about stars. You know, those giant blazing furnaces way up there in the sky. What if that was just scratching the surface? Just one layer of something much deeper, much more astonishing. For generations, really, we've looked up, feeling pretty confident we understood them, driven by heat, by gravity, right? Brute force. But what if the universe and these cosmic giants don't just run on thermodynamics? What if there's something else? Something more subtle, more organized, maybe even intelligently structured by underlying fields?
That's exactly the territory we're stepping into today. It's a pretty radical proposition, actually. We're looking at a groundbreaking new framework, and it doesn't just tweak our understanding of stars,
Yeah.
how they're built, how they evolve. It fundamentally redefines it, and maybe most provocatively, it connects all of that to life itself.
Wow.
Yeah. Our guide for this is a 2025 paper by Philip Randolph Lillian. It's titled Stellar Coherence Dynamics, Hypergravity Structuring, Elemental Alchemy, and Field Symmetric Evolution in Stars and Life. Quite a mouthful, but it captures the scope.
Okay, so our mission today is to really unpack this model. It sounds incredibly unified. We'll be getting into concepts that honestly sound a bit like science fiction at first glance: hypergravity, coherence fields, elemental alchemy. But as we go, we'll see how they might reveal these surprising, almost poetic connections between the biggest things out there, stars, and the tiny, intricate processes in our own biology. So, yeah, get ready for maybe a significant shift in perspective on the cosmos and maybe our place in it. Let's dive in.
All right, so when we think about stars, the standard picture, the one you get in Astronomy 101, is pretty clear, right? Giant balls of incredibly hot plasma.
Mm-hmm.
And we're told the energy source is thermonuclear fusion, deep down in the core. Intense heat, intense pressure. It overcomes that natural repulsion between atoms, the Coulomb barrier, forces them to fuse, release energy. It's a really elegant model, and it's served astrophysics incredibly well for decades. It's the foundation. And absolutely for good reason. I mean, the standard stellar model explains a huge amount of what we observe. It's robust. But Lillian's stellar coherence dynamics model comes along and suggests that, well, maybe these conventional models focused on thermodynamics and plasma, maybe they obscure more fundamental coherence dynamics.
Obscure. So, like, they're not wrong, but they're missing the deeper layer.
Exactly. The paper argues we've been looking primarily at the effects, the heat, the light, the pressure, but maybe not the underlying cause. The core idea here, it's a big shift, both physically and philosophically. It's moving beyond just heat and pressure as the absolute drivers. This new framework suggests the universe is fundamentally governed by something called coherence field physics. And in this view, the most radiant things we see, stars, they actually operate more like resonance-driven coherence engines, orchestrated by these subtle underlying fields.
So it's not just looking through a different lens. It feels like stepping into a different dimension of physics almost.
Sure.
Instead of just particles randomly banging into each other in a hot soup, you're talking about a field-intelligent universe where these organized fields are playing the main role, guiding things. That's a huge departure.
It really is. Think of it less like, cosmic billiard balls colliding randomly. It's more like an underlying symphony that's incredibly finely tuned. This model introduces this foundational layer defined by the coherence, the organization of these fundamental fields. And traditional models, well, they don't really count for that directly. It suggests that what we see as heat or pressure are actually just emergent phenomena. They arise from these deeper coherence dynamics.
Okay, conceptually, I think I'm following. But if it's not just about heat and pressure defining the star, what is defining the stellar core in this new framework? What's fundamentally different about the heart of a star if it's not just a giant thermonuclear furnace? Where does this coherence start?
And this is where the model really makes its most dramatic claim. In stellar coherence dynamics, the stellar core, it's not seen as a conventional fusion zone at all. Instead, it's thought of as a coherence compression chamber. And the key concept here is something called hypergravity.
Hypergravity. Okay, sounds intense.
It does. But Lillian defines it very specifically. It's not a force like gravity as we normally think of it. It's described as a dense, pre-dimensional coherence phase state. Imagine, like an incredibly tightly packed, perfectly organized state of information or energy that exists before space, time, or even the fundamental forces as we know them fully emerge. And this hypergravity state, it essentially seals this core zone. So the core isn't just hot plasma anymore. It's explicitly described as a site of profound nuclear alchemy.
Alchemy.
Yes, continuously producing exotic nuclei and coherent structured matter. It's a stark contrast to the standard picture of just superheated hydrogen and helium fusing.
So, wait, the actual stuff in the core, It's not just super hot gas, it's something else entirely, like some kind of exotic, highly organized state of matter. Can we even call it matter in the usual sense?
It is matter, but yeah, in a truly unique state.
Mm.
The paper calls it a transnuclear state, and its defining feature isn't chaotic kinetic energy, particles bouncing around like crazy. It's resonance-layered coherence. So think less heat, more structure, like a highly organized, maybe even crystalline-like resonance structure of the fields themselves, and the nuclear alchemy happening there.
Yeah.
It's not about violent collisions overcoming barriers. It synthesizes elements through coherence-induced resonance interactions.
Okay, coherence-induced resonance, like tuning forks vibrating together.
That's a good way to think about it.
Yeah.
Imagine this colossal cosmic orchestra, where the precise frequencies and harmonies of these fields allow elements to just form and transform spontaneously. It's not forged in some brutal furnace. It's a continuous, ordered process driven by field resonance.
That sounds incredibly complex, but also strangely elegant. If this is happening in the core, how do these coherence fields coming from this hypergravity zone actually create the stars structure that we do see? We know stars have layers, core, envelope, atmosphere. How does this model explain that familiar structure?
That's a really crucial point, and the model offers a quite beautiful reinterpretation of stellar anatomy. Those layers we know, the core, the envelope, the plasma sheath, recast as coherence phase gradients. These layers, according to Lillian, get organized through the process of hypergravity itself, sort of relaxing, gradually reducing into emergent field symmetries as you move outwards from the core. It's like a structured unfolding of the universe's fundamental forces, from that unified state at the very center to the more familiar forces we see further out.
So these layers are literally manifestations of different fundamental forces emerging. What exactly are these symmetries, and how do they create the distinct layers? How does an abstract idea like symmetry build a physical star layer?
Right, so in this view, gauge symmetries, the mathematical rules describing fundamental forces like electromagnetism or the nuclear forces, they don't just randomly appear. They emerge in a sequence based on how steeply the coherence gradient changes as you move out from the hypergravity core. The steepness determines which symmetry crystallizes out, so to speak. And these symmetries define the layers. So the very center, you have the core, the coherence compression zone. That's the hypergravity-sealed alchemical region, most dense, most coherent. Then, moving outwards, you hit the intermediate shell. This is described as a bivector electromagnetic envelope. This layer emerges as hypergravity reduces into U1 gauge symmetry. That's the symmetry linked to electromagnetism. But these aren't just any EM fields. Lillian proposes they are bivector EM fields, organized into specific toroidal and polar lattice structures, like an invisible scaffold. And here's the key bit. These organized EM structures are what govern the plasma behavior and light emission without needing constant high-temperature fusion throughout these layers. The star's structure and radiation rely on these ordered fields, not just internal heat pressure.
Wow, okay, so it's actively structured by electromagnetism in a way we hadn't considered.
Exactly. And then finally, you get the outer plasma envelope, the dispersive field layer. This is the plasma we typically see, but it's composed of coherent plasma that's directly structured and animated by those EM field geometries from the layer just beneath it.
This implies a completely different mechanism for how the star holds itself together, doesn't it? It's not just gravity versus thermal pressure anymore. It sounds like the star has an internal skeleton made of field energy.
That's a great way to put it. Precisely. The standard idea of hydrostatic equilibrium, and the gravity balanced by thermal pressure, it gets radically reinterpreted here. The star's structure and stability are governed by this sequential emergence of forces, electromagnetism, U1, weak interactions, SU2, nuclear gluon fields, SU3, all arising from these steepening coherence gradients. There's something called the symmetry gradient function, which basically acts like a threshold equation. Depending on the local coherence gradient, it determines which gauge symmetry emerges. So yeah, picture turning a dial. As the coherence changes, different fundamental forces click into place, defining the distinct regions and behaviors within the star. It's an active, field-driven architecture, not just a passive balance.
Okay, but if this hypergravity-sealed core is so different, so dense, operating on these unique principles, why haven't we seen it? Why haven't our telescopes or detectors picked up on it? It seems like such a fundamental shift. You'd expect some direct evidence by now.
That's the critical question, and the model tackles it head-on. Lillian's argument is that our traditional tools, telescopes, spectrographs, even neutrino detectors, they're designed to look for luminosity, for thermal diffusion. They measure heat, light, pressure effects. What they're not designed to detect, or even capable of measuring right now, are coherence gradients. or these hypergravity states.
Hmm.
So the core's unique alchemical density, its coherent structured nature, it remains hidden from our current observational methods. And this blind spot, the paper suggests, is what creates the illusion of a purely radiative fusion-based model.
Hmm.
We're essentially only seeing the outer layers, the effects, the skin of the star, not the intricate coherence dynamics running the show underneath.
Okay, this is where it gets really wild. So the star's appearance, its mass volume stability, the fact that it looks like a stable, fairly uniform ball of gas that's actually a kind of cosmic optical illusion. It presents one way, but it's fundamentally different inside. That's mind-bending.
That's the powerful implication, yes. The model introduces what's called the mass-volume balance and dispersion principle. It basically says the mass-volume ratio we observe looks balanced because the outer envelope, the part structured by the more dispersive coherence fields, like plasma and radiation, effectively veils the denser coherence core processes. Wait, think of it like looking at a perfectly smooth, opaque marble. You see its round shape, its size, but you have no idea if there's an incredibly dense, tiny bead hidden right at its center. This outer envelope masks the hypergravity core and its alchemy, making it invisible to conventional observational models. So it's not balanced in the old sense of uniform density versus gravity. It's dynamically structured by these layered coherence gradients. The outer, more spread out fields visually and spatially compensate for the immense density packed into the hypercoherent alchemical core. The core is, as Lillian puts it, hypergravitationally sealed, both structurally and observationally. Our current tech just doesn't have the right senses to perceive it directly.
Wow, okay. This completely reframes how we look at something as basic as a star's size and density. It's not just what you see, it's what's hidden by these coherence fields. It really forces you to question, what's really there. There could be this whole unseen layer of reality driving things. Okay, so if the core isn't this brute force furnace and heat isn't the main driver, then how does energy production actually happen? How does fusion, as we've always called it, work in this model? The whole concept seems like it needs redefining.
You're absolutely right. The model draws a really stark contrast with our usual understanding of fusion. It expands the idea and defines three distinct fusion classes. Fusion class I is basically what we already know. Thermonuclear fusion. That's the classical picture. High kinetic energy, particles smashing together, overcoming the Coulomb barrier through shear force, plus some quantum tunneling. It's chaotic, needs incredible heat, happens in a decoherent environment. A proton chain in the sun. That's class I.
Right, the standard model.
Then we get something entirely new. Fusion class 2, coherence fusion. This is a novel mechanism. Here, fusion happens by matching coherence fields across the nucleus and its electron cloud. So instead of brute force, think of like two perfectly tuned instruments vibrating at just the right frequencies to merge. The Coulomb barrier, that repulsive force, it's reinterpreted here not as a solid wall of charge, but as a field phase discontinuity, like a misalignment in the fields.
Okay.
So fusion in this class is enabled by field rephasing plus symmetry compression. And here's the kicker. It can happen at low or even ambient temperatures. It doesn't need heat, it needs field tuning. It's about aligning fields precisely, not overwhelming repulsion with energy.
Wow. Field tuning, not heat. That's a game changer.
It is. And then there's the most extreme form, fusion class 3, torsion-induced fusion. This happens when a local coherence torsion, basically a vortex or twist in the field, collapses inwards. Picture a tiny cosmic whirlpool suddenly imploding. This collapse forces a coherence implosion, and it literally sucks in nucleons, protons, neutrons via intense field compression. It creates these pressureless but intense fusion zones, almost like fusion funnel. Lillian suggests this might be happening in places like quasar hypercores, driving extreme alchemy through collapsing field vortices. And beyond just these classes, the model also explains something called neutron ingress differently. Normally, a neutron needs a high energy impact to join a nucleus, but here, hypergravity, or just the right resonance field alignment, can effectively smooth out the coherence boundary around a nucleus. It makes the nucleus coherence permissive.
So it becomes receptive.
Exactly. It can absorb a neutron without needing that violent collision. And this mechanism, Lillian argues, could potentially explain things like observed low-energy nuclear reactions or cold fusion phenomena, maybe even elemental transmutation happening spontaneously without extreme heat. Elements changing identity through subtle field guidance, not just impacts.
Okay, if elements can be formed without needing extreme heat and pressure, does this completely rewrite the story of where heavy elements come from? We're always taught that everything heavier than iron, the gold, the uranium, the rare earths, they're forged only in these super rare cataclysmic events. Supernovae, neutron star mergers.
It absolutely does. And yet this is another profoundly counterintuitive piece of the model. Lillian directly challenges that standard narrative with the alchemy cascade hypothesis. This hypothesis says, no, elements heavier than iron are not formed solely by those rare explosive events like the R process in supernovae. Instead, it argues they are continuously generated in high torsion coherence zones. These are areas with intense swirling field vortices found within stellar cores, these proposed hypergravity chambers, and quasar hypercores. So the universe isn't just making heavy elements in these sporadic, violent bursts. It's doing it in a more ongoing, structured, ordered way through these coherent processes.
Wait. If this is right, then elements like gold or uranium, things we think of as incredibly rare, they could be forming continuously in places we never thought to look, just through a different, more subtle process. That's really something. The universe is a constant factory.
Precisely. This coherence alchemy, as it's called, isn't driven by impact. It's driven by phase compression, torsional resonance, and field gradient steepening. It allows atoms to emerge from symmetry phase reconfiguration, not brute force. The paper is explicit. This doesn't require neutron bombs or explosions. It's about rearranging the underlying field structures. And the model even gives examples of specific alchemical shell zones and predicts what they might produce, like deep inside stars, like our Sun GK stars, where there are moderate torsion gradients. The model suggests continuous production of elements from atomic number Z27 to Zn40, that's cobalt, up to zirconium, things like nickel, copper, zinc.
Stuff we normally attribute to earlier stellar generations or supernovae.
Right. Then you go to neutron star crust zones. Much higher torsion shear there, extreme conditions. It predicts elements Z equals 41 to Z60, niobium up to neodymium. That covers a lot of the rare earth elements. And then the most extreme, quasar hypercores, where coherence is near pure and torsion is maxed out. There it predicts continuous production of elements Z60. So heavy rare earths, actinides, and yes, things like gold and uranium.
Okay, this is fascinating, but it leads to a huge question for scientists. If this continuous alchemy is happening, what kind of signatures would we look for? How could we possibly verify something this radical, especially if our tools are mainly looking for heat and light signatures?
Yeah, that's crucial. The paper does suggest some specific, potentially testable outcomes. For instance, Lillian argues this model could better explain the observed abundances of certain rare elements we sometimes find in stellar atmospheres, or accretion disks, or even on exoplanets abundances that are sometimes hard to square only with supernova origins. But more specifically, it predicts we should find anomalous isotope ratios. The specific mix of isotopes for a given element would be different if it was formed via coherence alchemy compared to thermonuclear processes. These different isotopic fingerprints would be directly tied to the specific field phase coherence states where they formed. So it's not just finding gold, it's finding gold with a weird isotopic signature that points back to this coherence process. That would be a strong piece of evidence.
Speaking of things we thought we understood, what about neutrinos, those ghost particles? The idea that they oscillate, changing flavors as they travel, that's pretty standard particle physics now. Does this model mess with that too?
It offers a completely different explanation, yes. It reframes neutrino oscillations entirely. Instead of seeing it as the neutrino itself changing its flavor state while traveling through the vacuum, this model interprets oscillations as gradual coherence leakage events, events that happen as the neutrino crosses these hypergravity coherence field boundaries within the star.
So neutrinos aren't just particles interacting weakly with matter, they're more like fragments, or little whispers leaking out from the star's core coherence. That's a really different picture.
It's a profound shift. A neutrino, in this view, is a quantized resonance leakage from deeper phase-locked coherent structures inside the star. It's oscillation, the apparent change in flavor. That's not the particle changing itself in flight. It reflects partial coherence reabsorption or shell-to-shell resonance tunneling as the neutrino moves through the star's different coherence layers or phase domains. They become essentially a direct signal, an echo of the star's internal field state and coherence dynamics. The model even puts forward a coherence leakage equation. Conceptually, it links the observed neutrino flavor mix to the star's internal coherence functions and the local torsion gradients it passes through. And this implies that the apparent mass ambiguity we see in neutrino experiments, why they seem to have slightly different masses, might actually come from the varying torsion resistance they encounter during this leakage process, rather than fixed inherent mass differences between the types.
Wow.
And the predictions are fascinating too. It suggests oscillation length could vary depending on the coherence density of the environment the neutrino travels through, not just distance. It even posits phase-locked neutrino reservoirs, huge, hidden collections of neutrinos stored in interstellar space or galactic boundaries. And crucially, it predicts that the changes we see in neutrino flux from the Sun or other stars would be tied to shifts in the star's internal phase resonance, not simply the rate of core fusion. This could totally change how we interpret data from neutrino telescopes. They might be probing coherence, not just fusion.
Okay, if stars are this different, operating on coherence, what about the real monsters of the cosmos? Black holes, quasars, we usually think of them as the ultimate endpoint of gravity, or these incredibly bright beacons fueled by matter falling in. How does this model see them?
Again, a radically different perspective. Lillian proposes that black holes and quasars are not simply endpoints of gravitational collapse, in the usual sense matter crushed to a point. Instead, they're described as highly dynamic coherence phase chambers, places where hypergravity intensely modulates how fundamental symmetries emerge and revert. They aren't just sinks or lights, they're engines of cosmic reordering.
So not cosmic vacuum cleaners or lighthouses, but more like cosmic reset buttons or transformation hubs.
Exactly. At their very centers, they undergo something called a symmetry collapse cascade. The coherence gradients become hyperfinite, incredibly steep, incredibly concentrated. This leads to a symmetry reversion. The fundamental forces essentially rewind their emergent sequence. The strong nuclear force, SU3, reverts back to weak interactions, SU2, which reverts back to electromagnetism, EU1, and ultimately it reaches C3, the infinite coherence constant.
Infinite coherence constant.
Yeah, representing a return to the purest, most unified state of coherence, the original hypergravity state, basically, an omnilectic symmetry. And their internal structure is described through this lens, the outer torus of a quasar, that bright swirling disk we see. That's characterized by highly torsional plasma. Here, the U1-SU2 interactions, electromagnetic and weak, are dominant, and the model says this is what generates the powerful synchrotron jets we observe. Deeper in, there's a core collapse zone. This is seen as a coherence shell rupture. Here, the SU3 interaction, the strong nuclear force, becomes intense, leading to nuclear alchemy ignition. This suggests quasars could be massive factories for heavy elements, forging them through field compression, not explosions. And right at the heart is the hypercore node. This is where pure symmetry implosion happens, where everything reverts to that C-show state. This results in a massive, coherent radiative outburst, which is what we perceive as the incredibly intense, structured light and energy funnel of a quasar. But what's really key here is Lillian's emphasis that quasars act as symmetry reversion points. They aren't just destroying matter.
In this model, they're actively restoring universal coherence. They've taken accumulated asymmetry and injected a structured radiation. They're maintaining the balance of fields across the cosmos, a cosmic recycling plant for fundamental forces.
This model really does start with the star, redefines something as basic as sunlight, but then it just keeps going, extending these principles all the way to life itself. That's a huge leap, connecting astrophysics to biology.
Yes, and this is arguably where the model becomes most profound and maybe most controversial. It claims these same principles of coherence dynamics aren't just for stars and quasars. They're universal principles of field-guided alchemy. Lillian defines resonant transmutation fields. These are structured coherence matrices, like energy patterns, that he says are capable of modulating atomic identity without particle ejection or fusion heat, meaning elements can literally change their nature under specific tuned field conditions, not just through nuclear reactions.
Okay, wait, let me make sure I'm getting this. You're saying elements can change identity, not just in the crazy conditions inside stars, but potentially under stable, normal conditions, guided by fields. That implies matter is fundamentally fluid in a way. That's mind-bending.
It is. The field-guided transmutation principle basically states that matter is field-tuned. An atom's identity isn't just fixed by its protons and neutrons alone. It's deeply influenced by its embedding in a specific coherence-resonant shell structure, the energetic field environment it's in. And if you could precisely alter that field environment, its gradient, its twist or torsion, its boundary resonance, then elemental transmutation can occur. And Lillian is very clear. This is not nuclear fission or radioactive decay. It's field symmetry redescription. The element is essentially changing its resonance signature in response to the surrounding field music. And the examples given are striking. Beyond the astrophysical alchemy in stars and quasars, he points directly to biological transmutation. This refers to things like low-energy field modulations, potentially explaining those weird, long-observed but hard-to-explain calcium-potassium shifts in living tissues, like bone healing. The idea that our cells might be doing subtle alchemy at body temperature. Yeah. And it even opens the door speculatively to artificial coherence chambers. Imagine engineered devices that could use carefully shaped fields and resonance cavities to guide atomic identity, maybe even structure matter directly through torsion fields. transmuting materials on demand. It's far out, but it follows from the core principles.
Okay, if transmutation could potentially happen in biology, what does that mean for how our bodies actually work? Are our cells doing something way more sophisticated, almost alchemical, than just basic chemistry?
According to this framework, yes, absolutely. It proposes living systems aren't just passive bags of chemicals reacting. They are active, resonant coherence engines. Our cells, Lillian suggests, precisely regulate their elemental makeup and function using sophisticated field-based tools, torsional phase control, shell resonance alignment, biofield coupling. It suggests biological transmutation isn't random, it's a coherence-guided alchemical transformation governed by subtle elemental intelligence. Our biology itself is seen as a direct manifestation of these deeper field dynamics.
So our cells aren't just little chemical factories. They're performing this subtle alchemy guided by the same universal coherence fields that shape stars. That makes our bodies sound like miniature biological stars operating on the same cosmic rules.
In a very deep sense, yes. The model suggests the same coherence principles apply. It even details possible mechanisms of biological alchemy. For transmutation, it points to field alignment plus a subtle shell shift. The classic example often cited in these circles is potassium, K, seemingly becoming calcium, Ka, during bone formation when dietary calcium is low. The models suggest this isn't chemical, but a field-guided elemental shift. For isotopic selection, it talks about coherence phase matching. This might explain how life preferentially uses certain isotopes like modulating hydrogen H to deuterium-D or even tritium-T in metabolic pathways, something standard chemistry struggles to fully explain. And for elemental attraction, it suggests biofield resonance locking. This means essential elements like zinc, iron, selenium aren't just absorbed passively, they're actively guided to specific cellular locations or enzymes because their unique coherence signatures resonate with the biofield of that target site. The model introduces this idea of an elemental coherence signature. Each element has a unique resonance pattern, like its own note, and this signature interacts profoundly with our DNA, with the water in our cells, with microtubule fields. Trace elements, things like gold, lithium, copper, they aren't just inert bystanders or simple cofactors. They function as phase keys. They play crucial roles in genomic tuning, maybe influencing emotional resonance, guiding how tissues develop their form. Morphogenesis. For instance, Lillian suggests gold might align with the helical curves in DNA, lithium could bind to sites that dampen torsion to regulate processes, selenium might couple to specific resonant folding points in DNA to affect gene expression.
It's fascinating, the idea that our bodies aren't just chemical machines, but these dynamic field intelligence systems. Orchestrating elements at this fundamental level, it suggests such a deeper layer of connection to the intelligence of the cosmos itself.
And right at the heart of this biological alchemy, the model points to something we all know, but perhaps see in a new light, DNA itself.
Right, DNA, the blueprint, the master molecule. We think of it as the code that dictates everything about us. But it sounds like this model takes DNA way beyond just being a passive instruction manual.
It absolutely does.
And
Lillian presents this really radical idea. DNA is more than a biochemical sequence. It actually functions as a complex torsional resonance gate. It dynamically modulates the flow of coherence. It enables fields to phase lock onto biological processes. It even grants transmutation permissions, that iconic double helix structure. Not just for stability or coding, it's a precision-tuned coherence interface. It's interacting directly with these cosmic fields. It's like a biological antenna, maybe even a cosmic tuner.
So DNA isn't static code. It's a dynamic switchboard for cosmic fields, actively mediating energy flow, maybe even elemental changes. That's extraordinary. It brings a whole new, almost mystical dimension to what DNA is.
It is. And the model tries to break down how it might work, describing several functional layers of the DNA gate. First, the helical geometry itself, that twist, is perfectly suited for torsional modulation, resonance alignment, and harmonic gating. The shape allows it to interact with and process these subtle torsion fields, like an antenna shaped for specific frequencies. Then the base pair code, the AT-GC sequence, reinterpreted not just as code, but as a field encoding matrix. It's actively attracting and locking in specific coherence eigenstates from the universal field, translating these field patterns into biological organization. Third, chromatin folding, how DNA is packed and coiled in the nucleus. This isn't just packaging. It acts as a phase compression regulator. It can literally open or close access for these fields, allowing or blocking transmutation or regeneration processes at specific times and places. And finally, the epigenetic surface, those chemical tags on DNA that change gene expression without changing the code itself. This is seen as the site of environmental modulation. It suggests external fields, maybe from stress, light, sound, other subtle energies, can directly tune these torsion gates on our DNA, impacting our biology at a really fundamental level. The model even suggests DNA positions elements not just by chemical fit, but by resonance symmetry. Gold aligned with the helix curve, lithium binding to torsional dampening sites, selenium coupling to resonant fold points. It paints DNA as this incredibly sensitive field-responsive structure, orchestrating a much bigger dance than just proteins.
Okay, if DNA is this coherence gate interacting with cosmic fields, what does that mean for evolution, for how life develops? The standard picture is so heavily based on random mutation, natural selection, chance, and pressure. Does this model offer a completely different story for life's journey?
It's a very different narrative, yes. A crucial departure. Lillian's model directly challenges that view of evolution as primarily random mutations filtered by the environment. Instead, it proposes that biological evolution, and also morphogenesis, how an organism develops from an embryo, are coherence-guided phase unfolding processes. Organisms develop, adapt, and evolve, in this view, not by chance, but according to inherent internal resonance logics. They structure their form through field matching, symmetry bifurcation, and torsional memory. There's an inherent intelligence guiding the unfolding.
So life isn't just randomly bumping around, reacting to the environment. It's unfolding based on these built-in, structured coherence patterns, almost like following a pre-existing but flexible cosmic score. That sounds much more deterministic in a way, but also more intelligent.
It is. It's definitely less random. The model calls this coherence morphogenic dynamics. For form generation, how we get complexity from simplicity, like Lynn's developing it, talks about symmetry bifurcation. Field patterns guiding the initial splits and differentiations, unfolding specific forms from underlying field geometries, not just chemical signals. For patterning how body plans are laid out, the beautiful patterns in leaves, photosynthesis, complex networks that's attributed to field resonance imprint. The blueprint is energetic, not just chemical. Adaptation is seen as a torsional memory update. This includes epigenetics. Organisms adjust by fine-tuning their field interactions and resonance patterns, allowing for rapid, potentially guided responses, not just waiting for a lucky mutation. And maybe most strikingly, an evolutionary leap, like a new species appearing relatively suddenly in the fossil record. The model suggests this isn't just a gap in the record or a super-fast random process. It could be an attractor activation via torsion spike. Major evolutionary jumps might be guided activations of pre-existing coherence patterns, triggered when internal states align with external field conditions, like unlocking the next level in a pre-designed game. The paper sums up its biological view with this core idea. Life is not a machine. It is a coherence-unfolding intelligence. Organisms evolve, it says, when their internal torsion states align with external field attractors, activating pre-existing coherence patterns. Life inherently knows how to unfold, guided by this unseen network of fields.
This really is a unified model, then. It connects the absolute largest scale stars, quasars, right down to the fundamental processes in our own cells, our DNA. It makes you completely rethink the connections across the universe. It's a truly grand, interconnected picture.
It really aims for that unification, absolutely. And of course, for any new model, especially one this comprehensive and frankly this challenging to the status quo, to gain real traction, it needs to make testable predictions. It can't just be a nice story. So the paper does spend significant time proposing ways to strengthen its formalism, to connect it to observation, to generate specific predictive outputs that could, in principle, be tested against data. It's about moving from grand theory to empirical science.
Okay, so how would we actually test some of these really radical ideas about stars? What would be the smoking gun evidence that could maybe distinguish this coherence model from the standard thermodynamic one? What kind of experiments or observations could we even do?
Lillian puts forward some pretty specific and interesting proposals. For instance, the model suggests we could develop predictive equations for coherence phase shifts. These shifts in the star's internal coherence state, the model predicts, should lead to observable events. So instead of solar flares being random magnetic events, maybe we could predict specific stellar eruptions, or even predict dips in neutrino detection, neutrino coherence damping, based on measurable changes in the star's internal coherence state before the event. That would be powerful forecasting.
A new way to predict space weather, almost.
Potentially, yes. They also propose simulating how the plasma envelope structures light emission. This should lead to specific non-thermal signatures in the starlight, things like unique polarization patterns or magnetosphere shapes that look different from purely magnetic models, or maybe unusual ways the star's light flickers or modulates as it rotates. new things for optical astronomers to look for. And crucially, they introduce a coherence emission equation. This is proposed as a replacement for the standard blackbody equation, which links a star's brightness mainly to its temperature. This new equation says luminosity is governed by a coherence eigenvalue, related to the core's alchemy, the phase output, and a resonance dispersion operator. It fundamentally changes why stars shine. It's not just heat radiating, it's organized field emission. They also suggest reframing the solar magnetic cycle, including sunspots. Instead of just being areas where magnetic fields block heat from rising, some spots are reinterpreted as zones of localized coherence torsion accumulation, places where this field twist builds up and then releases, modulating the EM bivector shell, a different physical driver for solar activity. And things like high-velocity plasma jets, CMEs blowing off the sun, spicules shooting up. The model sees these not just as magnetic explosions, but as ruptures in coherence continuity along torsional field lines, propelled by a coherence rebound effect, like releasing a wound-up spring, potentially different energy source. And then there's the big one, the high solar atmospheric temperature, the corona mystery. Why is the sun's outer atmosphere millions of degrees hotter than its surface? Huge puzzle. This model suggests the corona isn't heated conventionally from below. It's energized by coherence wave interference patterns from EM bivector fields. These waves coming from deeper inside constructively interfere way up high, creating quantized coherence amplifications perceived as high temperatures, like overlapping waves creating peaks, but with coherence energy perceived as heat.
Like focusing sound waves to create heat.
Something conceptually like that, yes. And finally, the photonic energy emission levels the star's spectrum, the specific colors or wavelengths of light it emits. The model says these are governed by coherence resonance layers. The intensity of light at a specific wavelength isn't just about temperature. It's proportional to the phase shear gradient and the bivector interference amplitude. Each spectral line, Lillian suggests, would correspond to a specific phase depth, a resonance tier, a bivector interference node within the star's coherent structure. This could open up entirely new ways to probe stars using spectroscopy.
That's a lot of potential observational hooks, and it definitely suggests, as you said earlier, a completely new way to classify stars, moving beyond just plotting temperature against luminosity, like we do with the standard Hertzsprung-Russell diagram.
Exactly. The paper explicitly introduces the concept of a coherence Hertzsprung-Russell, CHR diagram. It's meant as a powerful new tool to reinterpret stellar evolution, replacing those classical axes with parameters derived directly from coherence dynamics.
So what are the new axes on this CHR diagram? What are we plotting instead?
Okay, so the new x-axis is coherence resonance tier. This reflects the layering and complexity of the star's internal coherence phase structure. Think of it like how organized or sophisticated the star's internal field structure is. The new y-axis is coherence density output. This represents how much coherent mass energy the star projects outwards through field resonance, rather than just raw thermal luminosity. It's a measure of its efficiency in radiating organized field energy. So on this new diagram, the traditional spectral classes, OB stars, AF, GK like our Sun, M stars, even white dwarfs and neutron stars, they all get recast based on their coherence properties. For instance, hot, massive OB stars. They might be described as having high torsional frequency and coherence shell, unwrapped rapidly, high radiation leakage, reflecting intense internal field activity spilling out. Stars like our Sun, GK, may be bifurcation resonant with moderate coherence density output, their emission more symmetry-bound, buffered by coherence. And things like white dwarfs and neutron stars, usually seen as dead remnants, they become collapsed core resonance objects. Extremely high but localized coherence density output. A phase-bound coherence kernel emitting quantized leaks. It's a totally new map of stellar evolution, focused on the unfolding and transformation of these coherent field states, not just a star running out of fuel.
This model is just incredibly comprehensive. It weaves together stellar cores, black holes, element formation, neutrinos, and then connects it all the way down to DNA and biological evolution. The implications are just vast for physics, for biology, for how we see everything.
It really is ambitious in its scope, and that's the ultimate takeaway Lillian seems to be aiming for. The paper emphasizes its ontological depth and systemic unification. It wants to move beyond just thermodynamic reductionism, explaining everything purely by heat and energy. It introduces this layered, dynamic, resonance-based view. It integrates coherence, redefines hypergravity, explains force emergence, posits hidden alchemy. It's aiming for a truly holistic theory of existence.
It is a really beautiful thought, isn't it? That the deep principles governing the heart of a star could genuinely be the same ones guiding our own biology. The unfolding in our cells, in our DNA. It makes the universe feel less like just a collection of separate things happening randomly, and more like a single, incredibly intricate, interconnected, maybe even intelligent design makes everything feel, well, deeply alive.
And that's the final overarching statement from the source material, really, that this is proposed as a unified model in which stellar, atomic, and biological systems are all coherence-resonant processes of a field-intelligent universe. It suggests this profoundly interconnected reality where intelligence isn't just something biological brains have, but might be inherent in the very fabric of the cosmos itself, unfolding everywhere from the subatomic to the galactic.
Wow. Well, there you have it. Stars as coherence engines, elements being cooked up continuously through alchemy, neutrinos as whispers of resonance, black holes as cosmic reset buttons, DNA as a dynamic gateway to cosmic fields, and evolution as this guided, coherent unfolding. It's definitely a lot to chew on, challenges a lot of established science, but it's incredibly thought-provoking.
And perhaps a final thought to leave listeners with. If our universe is truly field intelligent, as this model suggests, and if everything from stars to our own selves are indeed coherence-resonant processes within that vast intelligence, what new responsibilities or maybe what new potentials might that reveal for us? As conscious participants, as living embodiments of this grand, unfolding cosmic intelligence, what does it mean for us to be part of that?
That's a powerful question to ponder. It certainly challenges us all to look deeper beyond the surface appearances, beyond what we just assume is fact, to consider a universe that might be far more interconnected, far more intelligent, and far more resonant than we ever imagined. Thank you for joining us on this deep dive.